Chapter 2, we start talking more about various functions, modeling, some of the higher degrees, and looking at what all we can do with them. In lesson 2.1, it is linear and quadratic functions that we're talking about. I believe, if I recall correctly how I have it broken up, we're focusing on the linear right now in 2.1, part 1 or day 1. And then in part 2, we will focus on the quadratics. And that will probably be next week unless we get to it tomorrow. We'll see. Okay, so now some review here. This is vocab from algebra. Polynomial functions. Okay, when we refer to a polynomial, any function that is a sum or difference of x values having whole number powers and real number coefficients. So when we talk about a polynomial, we're talking when there are terms that are added and subtracted together, and just your basic terms, like 3x squared, 2x to the fifth. Nothing fancy, okay? Whole number powers. So your powers are all positive whole numbers, no fractions or negative in your exponents, and real number coefficients. Okay, those are polynomials. So with that in mind, we have some that have specific names. Okay, if I start down here at the bottom of this chart, a cubic function. If I talk about something that's a cubic function, hopefully in your mind that comes to matter of, oh, that means the highest power in a cubic function is the power of 3, right? It's an x cubed. You may or may not have all of these pieces of ax cubed plus bx squared plus cx plus d, but the cubic has the highest power of 3. When we talk about the powers, that tells you what the degree of a problem is. Okay, so it's degree 3. And then your leading coefficient is always the coefficient in front of the highest power. So thus the a value. Quadratic, you guys are familiar with quadratics. Quadratics, not 4, but 2, right? Highest power of 2, ax squared plus bx plus c is your basic form there. Highest power 2, so it's degree 2. Leading coefficient is whatever's in front of that x squared term, so a. Linear, something's linear. Those are our lines. Those are the highest power is 1. And so you'll notice ax to the first plus b, degree 1, leading coefficient a. The one before this, a constant function. Okay, if you just have y equals a number other than 0, realize, first of all, there's no x. It's like an x is 0, so it's degree 0, leading coefficient is still a. Those are your horizontal lines. Okay, they have a slightly separate classification than linear. And then you don't usually see this one at least in a list. But they also in this book list zero function. Zero function just being when it's y equals 0. Okay, not some number. The degree is undefined there, and the leading coefficient is 0. Okay. Those are your special polynomials. Those are ones you saw in algebra. Okay, that's a lot of vocabulary you saw in algebra. So kind of the algebra review here. Let's go through example 1, looking at which of the following are polynomials. Okay, so either yes, it's a polynomial, it meets that definition up there, or no, it's not a polynomial. And then if it is a polynomial, we're going to talk about the degree and leading coefficients. If it's not a polynomial, we're going to talk about why it's not. Okay, so remember, if it's a polynomial, it's a sum and difference of different x values, whole number powers, and real number coefficients. Okay, thoughts on A. F of x equals 4x cubed minus 5x minus 1/2. Is it a polynomial?
Yeah.
Sum and difference of different x values?
What does that mean? Sum and difference of different.
Just basically it's numbers added and subtracted together. It's not going to be a polynomial if you have, like if it's a big old fraction or something. If you have 2x minus 3 divided by x plus 1. That's no longer a polynomial because you've got a big old division there. Okay, just terms added and subtracted together, basically.
So, yeah.
Okay, it's terms added and subtracted together. Do I have all whole number powers?
Yeah.
Yeah. What are whole numbers for the record?
1, 2, 3.
1, 2, 3, 4, and don't forget,
Negative. Does negatives count?
negatives do not count.
Negative.
That's good to know as we move forward. Negatives do not count because negatives take us into integers. So whole numbers are the positive whole numbers, for lack of a better word.
Number 2 not a polynomial.
Okay, so is A a polynomial?
Yeah.
Okay, it is a polynomial. If it is a polynomial, we're being asked to state the degree and leading coefficient. So, let's talk degree here. What degree would this be? Rebecca? 3. The highest power is 3. So this is a degree 3. You could write 3, or you could use the word, I mean, it is a cubic. I guess when you ask for a degree, it's usually a number, but it is also a cubic. And then the other piece of information we're asked for is a leading coefficient. Okay, if your degree is 3, then what is the coefficient on that term? And that is 4. Okay? Very basic algebra review, yes? But also vocab that we need to review. Okay, B. G of x equals 6x to the negative 4th plus 7. Is this a polynomial?
No.
Why not?
Not whole numbers.
Okay. If it is a polynomial, my powers are only whole numbers, which means my powers are only positives. We have a negative power. That's not a whole number. And so, no, this is not a polynomial. So, answer is no. It did ask us to state why. So, I'm going to write that the power is not a whole number, or power is negative. I guess I'll put power is not a whole number, and then in parentheses I'm going to say negative. Okay. C. H of x equals the square root of 9x to the 4th plus 16x squared.
I think so.
This is a polynomial.
I think so.
Why?
I don't think it's exactly divided. I mean, square root, I guess, can be like dividing. So,
Is this the sum and difference of x values?
yes.
Sum and difference of x values, but what's the catch?
Square root.
They're under a square root, yes? Now, for the record, let me tell you what this is not equal to. This is not equal to 3x squared plus 4x. You cannot do a square root of just individual terms when there's a sum there. Okay, with that in mind, that square root has to stay. Which means this could also be 9x to the 4th plus 16x squared raised to what power? What power is a square root?
1.5.
Remember, it's a fraction, right?
Which is multiplying. So therefore, It's not
Okay.
polynomial.
Well, it's not a polynomial, I would say, because it's raised to a non-whole number power. Okay, that would be my thing. A square root is never going to be part, unless it's just a square root of just like, well, no, even then. Yeah, I guess unless it's just a square root of a number out front. But if you've got x's and stuff under square roots, they don't simplify nicely, like this one doesn't. This is not a polynomial. Let's see. Again, I can write that, I can use the explanation that the power is not a whole number. And the catch is there is a square root. Okay, are we convinced on C all right?
Yeah.
Okay. What about D? K of x equals 15x minus 2x to the fourth.
Yeah.
Is it a polynomial?
Yeah.
We have x terms being added and subtracted, whole number powers, real number coefficients. Okay. I can agree that yes, this is a polynomial. If this is a polynomial, we need to talk about the degree and the leading coefficient. Thoughts on the degree?
4.
Why 4?
It's the biggest one out there.
Okay. Highest power, yes. It doesn't matter that it's not the first power. It is the highest power. So that makes this polynomial have a degree of 4. What's my leading coefficient then?
-2.
The number in front of that highest power term, and so leading coefficient of -2.
So it's not the one that starts the equation, it's of the biggest degree.
Correct. Okay, so that leading coefficient specifically goes with the highest power with your degree problem. Okay, in other words, because I could rewrite this and put my highest power first, couldn't I? Okay, I don't, because at this point that's beneath you guys, kind of, isn't it? Okay, questions there? Okay, moving on then. Linear functions. By definition, a linear function is a polynomial of degree 1 with a leading coefficient equal to the slope. When we talk about linear, it reads as ax plus b for the purposes of this lesson, but you guys probably don't usually think ax plus b, you probably think mx plus b. Okay? A couple of things. Horizontal lines do not fall into this category of a linear function. Okay? Because horizontal lines are degree 0. Okay? They're not degree 1. And so horizontal lines are graphs of constant functions. So they are not linear. Vertical lines are not functions because they failed the vertical line test. So basically what I'm trying to say is when we're talking linear functions, we're not talking horizontal, because those are constants. We're not talking vertical, because those just aren't functions at all. When we talk linear functions, we're talking what I would call your typical line, but slant lines. Okay, lines that have a slope other than 0 or undefined. Okay. Now, example 2 is very much an algebra 1 problem, I would say. Also reviewed in algebra 2. the information expressed that they're giving you is expressed a little differently, but this is definitely not anything new. Write an equation for the linear function f of x such that f of negative 1 equals 2 and f of 3 equals negative 2. Okay, write a linear function, which means we're writing y equals
X plus B.
mx plus b. I guess I technically could say f of x, but you know. Now, thoughts?
You would make y2 and x negative 1.
I actually like it. This right here, f of negative 1. That's f of, what is that negative 1 in place of?
X.
X. So this is an x value. When you plug in an x value into a function, what do you get out? A y value. So when x is negative 1, you get y to be 2, or in other words, you get the ordered pair negative 1, 2. Folks, that is an upper level way of thinking. That is a fancy way for saying here's an ordered pair. When they're saying f of negative 1 equals 2, that's fancy talk for, oh, the ordered pair is negative 1, 2. They do that all the time in calculus. Okay, it's more normal that they're going to give you that than they're going to say negative 1, 2. So that also means if f of 3 equals negative 2, what ordered pair is this? 3, negative 2. So now we truly are back to algebra 1. Here are two ordered pairs, 2 points. Write an equation of the line.
So you would first find the slope, and then you would find the y-intercept.
You guys agree with that? First we find our slope. It's been a minute, I know. How do we find slope?
y2 minus y1, so x2 minus x.
Okay. I often, when I talk about finding slope, I often kind of shrink it down to y minus y over x minus x, with the idea that algebra 1 is old news. You understand that. But officially it is y2 minus y1 over x2 minus x1. It doesn't matter which ordered pair is 1 versus 2. If I say that's x1, y1, and that's x2, y2, it honestly doesn't matter which one's which. All that matters is however you subtract your y's on top, you do the same with the x's on bottom, right? So, are you getting a slope?
Negative 1.
You guys okay with that? I agree with the negative 1 once I get there. So right now we know that the slope is negative 1. We also need a b value. We have options of finding a b value.
Plug negative 1, 2 into y equals mx plus b will land your slope. So y would be 2, negative 1 would be m and x in this situation.
Okay. Are you guys following that? Use your slope. Pick an ordered pair. Does it matter which ordered pair you pick? No. Okay. If Logan picked negative 1, 2, Becca picks 3, negative 2, doesn't matter. No, they're going to get the same b as long as no one makes careless mistakes. Okay. So we're going to take these two and we're going to plug them into y equals mx plus b. So y is the 2, m is negative 1, times x is negative 1 plus b. Negative 1 times negative 1 is 1. So now I have 1 plus b is equal to 2. And if it's 1 plus b, we're going to Subtract 1, and we're going to get that b is 1. So now when you write your answer, what are you going to write?
Y equals negative x plus 1.
You guys okay with that? Negative 1x plus 1, which is negative x plus 1. Now, you could see, officially it said write an equation for the linear function f of x. You could very well just as easily see f of x equals negative x plus 1. It's equivalent. I personally will accept either or. Just a reminder, y equals f of x equals, those are equivalent statements. Okay? Okay. Continuing along then. Okay, the way my spacing worked out, we have some average rate of change information here, and then we'll look at examples on the back. Average rate of change. When we talk about average rate of change, basically average rate of change is a fancy way for saying slope. Okay? The slope of a linear function, we already talked about, y2 minus y1 over x2 minus x1, characterize something called the function's rate of change. Okay? For a linear function, which is what we're dealing with right now, the rate of change is basically the slope, and it's a constant value. Okay? In calc, when we start talking about rate of change and functions that aren't lines, it's a rate of change, an average rate of change for that specific area. For a line, though, the rate of change is the same all the way along because it's the slope of that area. Okay? All functions have rate of change based on different values for x. There's an average rate of change for a function given an interval. Okay. Now, average rate of change of a function from x equals a to x equals b. So on a given interval, as long as a and b are not the same, is f of b minus f of a over b minus a. Okay? With that in mind, f of b and f of a are what kind of values? They're the output values, so they are y values. B and a are your x values. So realize when it says f of b minus f of a over b minus a, it's just a different way for talking about y2 minus y1 over x2 minus x1. Okay? That's all it is. Side note here, they might tell you on the interval from x equals a to x equals b, they might tell you on the interval a to b. That's a different way for just giving you the interval. Okay? So, example 3, we're going to practice with some of these. Now, the catch is you may or may not always have numbers to work with. Just kind of depends. But we're being asked to compute the average rate of change. On example A, they give us the function of f of x equals x squared. They're asking us to do this on the interval from x equals negative 2 to x equals 0. So they give us a function. X equals negative 2 and x equals 0 are what kind of values? Those are my what? That's the interval we're working on in this particular problem. So when we start talking about it, I'm going to think of these as A and B. Okay, those are my A and my B values. My suggestion to get started is that we find f of A and f of B. So I'm going to have us go ahead and find f of negative 2 and f of 0. What about f of negative 2? What do we do there? Take negative 2 and square it. You're plugging it in basically, right? F of x is given as f of x equals x squared. So if we want f of negative 2, the rule says to do x squared. So we're going to do negative 2 squared. What is negative 2 squared?
4.
4. We also need to find our other endpoint, f of 0. So we take the 0 in and we plug it in. 0 squared is 0. So we just found here basically our f of a and our f of b. We found that f of negative 2 is equal to 4, and we found that f of 0 is equal to 0. Remember our formula, f of b minus a over b minus a. Well, if we're doing f of b minus f of a, that means in this case we're doing f of what? F of b, so f of 0 minus f of a, so f of 0 minus f of negative 2 over b minus a, so 0 minus negative 2. Fill in the numbers. What was f of 0? We found f of 0 to be 0 minus, what's f of negative 2? 4 over 0 minus negative 2. All I did was fill in the formula. Do the math. Should be getting an answer of negative 2. Are you with me or not?
Mm-hmm.
Yeah? Okay. Got quiet. So it's kind of like finding slope. It's just slope on a specific interval. You're given the endpoints, use those x's, find those y's, do the setup. Okay? So let's try B.
So what is the rate of change of measuring exactly? Like negative 2, what? If your answer is negative 2, what does that mean?
So it's the average rate of change. Basically, it's the slope of that section of graph. So this is saying on the parabola, y equals x squared, that the average rate of change from negative 2 to 0, okay, is going to be negative 2. So the average slope in that section, because it's not, keep in mind, the parabola is a curve, yes?
Mm-hmm.
It's not going to have just one slope, okay? It's going to have an ever-changing slope because the curve changes, right? And so this is the average slope, essentially, for that area, okay? Okay, B. F of x is now given as 3x squared minus 1. We have a new interval, negative 5 to 3. Negative 5 and 3 are going to be my what? That's your A and B. And technically, it doesn't really matter which is which. Traditionally, A is smaller, B is larger. In reality, it doesn't matter a whole lot. So we need to find those values. I'm going to find f of negative 5. I'm going to find f of 3. So when you plug in negative 5, 3 times negative 5 squared minus 1. What are you getting?
74.
Yep. 3 times 25 is 75, minus 1 is 74. if we plug in our other endpoint, 3. So 3 times 3 squared minus 1.
What is it?
3 times 3 squared minus 1 is 26. Because you would end up doing 3 times 9, which is 27, and minus 1. So we just found f of negative 5 to be 74, and f of 3 to be 26. Basically, you're thinking y minus y over x minus x, yes? Do I need to write it out in terms of f's? I don't know. Not necessarily, I guess. If I'm doing f of b minus f of a, it's f of 3 minus f of negative 5 over 3 minus negative 5. We found f of 3 to be 26 minus f of negative 5, so minus 74 over 3 minus negative 5. Well, 3 minus negative 5, that's 8. 26 minus 74. Is it negative 48?
Oh, I guess it does. I just flipped negative 5 and 3, but you get the same answer.
As long as you flipped it top and bottom.
Yeah.
Yeah. And negative 48 divided by 8 is negative 6. Yeah, and that's the key. A and B, it doesn't matter what you do first as long as you're consistent. Okay? So there we have negative 6. Okay. And C? Well, for f of x equals 16x cubed on the interval from A to C. What'd they change up here?
There's no B, and there's no numbers.
Well, they didn't give us numbers, did they? Okay. A and C are essentially my A and B, if you will. Okay. They just gave us different, instead. So, okay, let's go with the basics here. Think with me. What's f of A going to be?
0.
No. No. We're taking A, and we're putting it in place of x. What'd you say? 16a cubed. Basically, x, or A, goes in place of x. And do we know what A is? No, it's a place of a number, but it's really a variable. And so f of A is going to be 16a cubed. What's that mean about f of C? Same thing, right? You're taking x and replacing it with c, and so this is 16c cubed. Now, on top, or what are we doing? We're doing, in this case, it's going to be f of c minus f of a over c minus a, which is 16c cubed minus 16a cubed over c minus a. Now, we've got some cleanup to do. Okay. On top, what do both terms have in common?
16 cubed.
Well, but they're two different variables.
So 16.
Both terms have a 16 in common, right? So on top, I'm going to factor out GCF of 16. So I factor out that 16, and I'm left with c cubed minus a cubed, all divided by c minus a. Now, there's a right way and a wrong way to continue. The wrong way is what I know most of you want to do right now, and you want to cancel a c and cancel an a and say that's c squared minus a squared. That's the wrong way. Okay? Remember, you can't, terms that are added and subtracted, c minus a in the denominator, you can't cancel just a c or just an a. Terms that are added and subtracted, you have to cancel a factor, and that whole factor would be c minus a. On top, you could cancel a 16, or you could cancel a c cubed minus a cubed, but that's my only option at this exact moment. Now, how are your Algebra 2 brains feeling right now? Because here's the deal. C cubed minus a cubed factors. I taught it last year in Algebra 2. Have I reviewed it this year in pre-calc? Factoring the difference of cubes? I don't think I've reviewed it. No one's giving me that look like, oh yeah, we did. Okay, so my c minus a is going to stay on bottom. My 16 is going to stay on top. So this is a review. AKA I'm reteaching it because I know you don't remember it. C cubed minus a cubed factors into a binomial times a trinomial. Okay? First of all, start by taking each cube root. What's the cube root of c cubed? C. Keep that sign the same. What's the cube root of a cubed? A. Okay, so my first parenthesis is c minus a. Now, in the second parenthesis, we're going to use these perfect cubes. The first one is the square of the first cube root. Well, my first cube root was c, and so when I square that, I'm going to have c squared. Your middle term is these two terms multiplied together and using the opposite sign. So in other words, when I take c times a, ca, or I'm going to write mine as ac, and it's going to be plus ac. And then the last term is always a plus, and it's the last term squared. And so this is going to be a plus a squared. Okay? You learned this probably about 11 months ago because I saw it in my upcoming chapter. I'm getting ready to start in Algebra 2. So, now, what was the benefit of that? Do we have a factor that can cancel now? Yeah. The factor of c minus a can cancel with the denominator of c minus a. And that takes me to what remains? 16 times c squared plus ac plus a squared. And that would be your answer. We can't go any farther than that because I wasn't given numbers. I was only given variables as my endpoints. Okay? Okay. Then one other piece of this lesson, and for the most part I'll talk about tomorrow, but it has to do with linear correlation. Positive correlation, negative correlation, no correlation, scatter plots basically. Okay, so we'll look at some basic scatter plots, talk a little bit about them, but then we're also going to look a little bit about how we can use our graphing calculators to write an equation for the line. Okay, or review it, I think.
I can't find the L1. Try to find the L.
So we'll finish notes tomorrow, and then you should have work time.